Hey, what's up, everyone? It's Mr. Cloud coming back uh, to you guys from my house in Belmore, New York, in Nassau County. And the first part of this water pollution series discussed two issues that we're seeing here on Long Island. One being the Grum and Plume, which has PCB, trichloroethylene, making its way through the groundwater of Long Island from Bethpage down to North Massapequa. We also talked about issues with pesticides getting into the groundwater in Suffolk. And the second part of this water pollution series, we're going to talk about where does water pollution originate? Where does it come from? We're going to break down the different types of water pollution that you can see on Long Island and around the world. And we can start going through those in a little bit. The first thing I want to talk to you about is how does water pollution originate? Where does it actually come from? And there are two main ways in which this actually happens. First would be your point source pollution. Okay, so pretty much an example of point source pollution would be when you have something like Indian Point, where you have thermal pollution. And we saw those canals making their way into the Hudson River. We know exactly where that is coming from. So that's a point. So that point source pollution. Um, what you see up top here is an example of effluent making its way from an industrial source in Chicago. Okay, I'm kind of using my tools for the first time here, guys, to kind of show you exactly where that point source would be coming from. You actually can see it radiating into the river there. This is easily managed. It's controlled by the Clean Water Act. So we know exactly how much is coming out of these point sources and how to regulate it, and it's pretty easily detected. All right. The next part and the next way in which water pollution can originate is by non-point source pollution, and that's what's happening below here in this specific area um, down on the bottom right of the screen. Okay. So pretty much non-point source is from random locations, all right, such as from city streets, okay, or from rural homes, or from forestry, or from suburban development, or from cropland, okay, and it's really difficult to determine exactly where all this is coming from. So this is difficult to regulate, and it's a major problem. It adds to cultural eutrophication, especially with cropland and from animal feedlots. So it's very difficult to manage. So there's got to be like plans put in place in villages and towns to kind of ward off something like non-point source pollution. Okay, so those are the main varieties, and I hope that makes sense to you guys. Okay, next, what I want to do with you is talk about the main types of water pollution that we're going to see. Okay, the first type, guys, are called organic compounds, and we already discussed organic compounds with Grumman and also with the pesticides out east. The next, guys, is going to be sewage, and that could be raw sewage, it could be semi-treated sewage, and that's a problem, more of a problem in developing countries. We'll definitely get into talking about that. The same effects of sewage is what you would get from nutrient pollution. Okay. The next would be disease-causing agents. Your bacteria, your viruses, your E. coli, bacteria that will get into waterways. Sediment pollution. This could be from runoff from areas that have been deforested. It could be from runoff from agriculture, and that's when the turbidity of the water increases. Thermal pollution, that could be usually from power plants producing electricity, usually like a nuclear power plant or a coal-fired power plant, adding water that's at a higher temperature. And then also we're going to look at inorganic chemicals. Inorganic meaning not containing carbon. So we're talking lead, mostly mercury, like that. So in this video, I'm probably just going to cover, most likely, I'm thinking I'm going to cover organic compounds for sure. And definitely we're going to cover sewage as well. So let's get into organic compounds first thing out. Okay, so the most common ones that we're going to come across in APES class that you really want to know. All right, and I'll circle them now. Okay, I'm going to try to circle them freehand for you guys. All right. You definitely are going to want to know different types of pesticides. All right. So the first type here is that aldecarb that I mentioned, which is a carbamate. There's many different types of pollutants that will or pesticides that we'll mention. Carbamates are one, organophosphates are another, like DDT, and they attack the nervous system. Don't want to ingest it. Not a good thing. You're also going to run into us discussing dioxins. Those can come from any sort of burning, but for the most part, it can come from burning incinerated garbage. That's one major pollutant that can add dioxins to the air, which can then fall into waterways. And the key here, guys, is that most of these are carcinogenic. Okay, causes cancer, probably causes cancer. Not a good thing. PCBs are also something that we're going to come across, polychlorinated biphenyls. We got plenty of that in the Hudson River, thanks to GE. Thank you very much, GE, for that one. And lastly, trichloroethylene, which was most commonly used um, with dry cleaning, and that's come across our waterways in the New York metro area over the last 30 years or so. Okay, so those are your organic compounds that you're going to come across that have gotten into our waterways. Mostly they're carcinogenic. Okay, and that's pretty much all you would really need to know about organic compounds. Okay, next, guys, let's get into talking about sewage. Okay, all right. So, oh, that's brutal. Ooh, brutal. Look at that picture right there. I would not want to be anywhere near um, what's going on, all right, in this situation. Not good. So, what sewage is the release of wastewater into waterways. In this situation, this is non-treated raw waste. And what could that possibly do to a waterway? All right. Well, here's the main concepts with sewage. You're adding a tremendous amount of nutrients into the water. Okay. You're also adding disease-causing agents. Watch out. Okay, but what are the main threats? The main threats actually are enrichment and oxygen demand. So let's get into what I'm talking about there. Okay, so what happens is that you get sewage goes into the water, and that causes a nutrient enrichment of the water. Okay, ton of nitrates, and phosphates get in there, and this is the real story of eutrophication, something that we've gone over and talked about. When that happens, you get an explosion of algae, an explosion of bacteria, and then a tremendous amount of decomposition happening within the water. When that happens, it increases either biochemical, or another word for it would be biological oxygen demand. And when that happens, you get a dropout in oxygen levels. Okay, and that can potentially lead to fishes dying off. Okay, and we all know all about this. This is called eutrophication. So I'm going to show you an even better way of looking at this, and hopefully it'll make sense to you. Okay, here's a great graph over here that can help you guys out. So let's take a look at that, and we'll break it down even further by looking at another awesome thing going on. So this kind of shows us a situation within a river where you have a point source at 0, and the sewage is being dumped in at that moment. There's plenty of oxygen in the water, and then you get a spike in biological oxygen demand when the sewage is dumped. When that happens, oxygen levels drop out, fishes die. As you get further away, there's a recovery. Okay? So what is biochemical oxygen demand? So I'm going to read it off for you here. It's the amount of dissolved oxygen needed by aerobic biological organisms, aerobic, right, to break down organic material present in a given water sample at certain temperature over a specific time period. Wow, that's a mouthful. Um, so pretty much, guys, when biochemical oxygen demand goes up, what happens is that oxygen levels usually go down. Uh-oh, sorry about that. We had a situation with a Zoom there. Sorry about that. Learning how to use this right now. Okay. So, oh, it happened again. All right, back again. We had an issue with zooming in and out and in and out. Sorry about that, guys. So biochemical oxygen demand. So when that goes up, it's going to dramatically cause the oxygen levels to go down. So if that's not making sense to you, let's show you another situation. Okay, ooh, how cool is this? All right. So let's talk about what's going on here in this situation. Okay. So let me break out some more drawing tools for you here. Okay, we're going to go freehand and kind of break down the situation. Okay. So if I were to give you a little test here, I'd ask you, what kind of pollution is this? Okay. And personally, what I would say is I would say, boom, boom. I would say that this is point source pollution. Okay. So if you said that, you would be absolutely right. So we know exactly where it's coming from. So what's going on is we're getting dumping of sewage causes enrichment to go dramatically up. Plenty of nutrients within this water. When that happens, you get an explosion of algal populations, of bacteria, all that wild stuff, decomposition happening. Uh-oh, not good. So, if we look at this, right, at the main point where the sewage is being dumped in, right, you get a rapid increase of the BOD. When that occurs, you get a rapid decrease of dissolved oxygen levels. And then you get a septic zone that takes place. A lot of death that happens, not good. Okay. And then as you make your way downstream and the amount of nutrients is not as concentrated, all right, your oxygen levels will start to go back up again, back over here. And then as you make your way even further away from that point source, your oxygen levels will come back to normal. So the speed of the river has a lot to do with this. If it's a fast moving stream, it's going to be able to filter out water a lot faster. All right, but I hope that this little demonstration here is able to help you understanding what the relationship with BOD and dissolved oxygen. And lastly, the last point that I'd like to mention to you guys is that at the point where you have the sewage being dumped, okay, right over here, right in this general location over here, okay, you're also seeing, all right, what you're also seeing here is you're seeing an increase, all right, in temperature, okay? When that happens, the capacity to hold oxygen or dissolve oxygen, it's a better way to say it, goes down. Okay, so not a good thing. Okay. Anyway, so that's the deal with sewage. All right, and with nutrient pollution, and also we discussed organic compounds affecting waterways. In the next video, what we're going to do, guys, is we're going to discuss disease-causing agents. We're also going to get into sediment pollution, thermal pollution, and inorganic chemicals. So I hope this is really helpful for you guys. Take those notes, and we'll see you in class very soon. All right, thank you very much. Bye.